Trying this again. Damn phone. Anyway, doing a DraftScience video on the subject of the light stuff, whatever, version number, page number 5 or 6 or whatever it is. Doesn't really matter, right? So anyway, the comments on the last video, let's get to those quickly. Roberto 2 guy, Mr. Roboto. Regarding the double slit experiment, it's very easily explained using Feynman's multiple paths method. Pick a point on the screen, a photon can reach that point via only 2 paths. Yeah, well, there's probably more than 2, right? It depends on whether it goes interior to a slit or refracts off the corner of a slit, but whatever. Either it goes through one slit or the other. Well, that's true, but it goes there different ways, so the path length will be different. The difference in time between the 2 paths steadily increases as one moves to the point away from the center. So when one adds the amplitudes from the 2 paths, their sum will vary, thus giving us wave-like probability distribution. Yeah, well, it's not just wave-like; it has to be interference. But regardless, I agree that certainly you can establish that there's a certain. I mean, I think that there is just a simple physics of what takes place, and there's nothing too unexplainable. The other property you're referred to is spin, the intrinsic angular momentum of a particle. See, that one's a little tricky. I just don't know if photons have angular momentum. I mean, angular in terms of spin. So not sure I'm going to buy that one. Electrons, yes, but photons, I'm not sure. In contrast to orbital angular momentum, which depends on the reference frame from which it is measured. There is a beautiful proof that shows that spin is a natural consequence of combining the postulates of QM with the space-time symmetries of special relativity. Yeah, well, that sounds like a pile of crap to me. It unfortunately uses some rather obtruse mathematics. I'll look around to see if there's a more straightforward explanation. Yeah, well, whatever. Perhaps the science of understanding QM create a black hole in the nearby future. You should actually be the greatest possible fan of QM. Yeah, well, whatever. I don't think it's going to do that. So anyway, somebody mentioned some kook, Thomas Campbell. Yeah, some guy, let's see. Thomas Campbell's take on the double slit experiment is probably the most interesting. It's all over YouTube. Well worth listening. Now, it's just a pile of crap, sorry. Just this wacky stuff about mind-reading photons, and yeah, it's just absolute shit. So anyway, so Poodle Susan also made a comment on the what the fuck video. So I should be able to pull those up here. I should be able to pull those up here. Oh, yeah, this is it. I think there's a cool person, blah, blah, blah. Yeah, this is it. Yeah, my misery and me once again unblocked. What a joke. Anyway, not for a little while, fella. I just want to know if this has something to do with the Walter Russell cubic wave field and mirror cube. And if it's wrong, why? It would be nice if you would consider answering science questions at your DraftScience channel, because I have several. Yeah, well, I'm not opposed to that. I came about Ben Premier's mirror cube vids a few months ago by way of someone else, and well, anyway, yeah, I watched a couple of these videos. I couldn't make anything out of them. It's all mystical, whatever, art of human psychology is somehow mixed into quantum crap and blah blah blah. And yeah, no, sorry, I don't get any of it. It doesn't look like an explanation to me. It looks like a bunch of it looks like religion. It doesn't look like science. So no, thank you. So anyway, anything else I really have to take care of here before I move on? I guess not. I'll take care of the questions regarding my last video on the pi and numbers. You know, some people keep saying numbers are just an abstraction. I don't think they're an abstraction. They are. They function in nature. They're actually something. So I don't think it's just an abstraction. The relationships certainly aren't an abstraction. The relationships are real. The relationship between 2 and 2 being 4 is a real relationship. Other relationships are real. Whether pi is real, that's, yeah, that one we can throw out. And if there was any, well, I don't want to do that video now. So anyway, getting back to the Feynman wave particle blah 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 thing, because that's the subject of this video. So now I'm on this subject of this, instead of the two slit, let's use this this experiment that had to do with the thickness of glass. And so the point being made is, say this is a thickness of glass, and what happens is, I guess I should have made it thicker. Anyway, the idea is how much light reflects back, and at what layer does the light reflect back. Obviously you would assume that it's reflecting from more than one surface, and the problem would be is that how would this surface, if it reflected here, be able to tell this surface that it already reflected here, this kind of stuff, and it would create all kinds of insanity. And so anyway, what turns out to be the truth here, I mean what time turns out experimentally, is that you end up with this wave pattern of a probability. Now this is with glass of one color, so it's mono, which is important, so we'll put that word over here just so we have it for later. These are somehow important facts. And so what happens is there'd be an average rate of 4% of the glass, of light, would reflect off the glass. That would be the result you get, regardless of how it happens. You get this number of 4% on average for an average piece of glass. But as you vary the thickness of this glass, you can get this number 4% to go all the way up to 16%. And what it will do, depending on the thickness of the glass, you apparently can also get it to go to 0. So this would be the 0 line here, and this would be 16% of the glass of the light reflects. So this is the pattern you end up with specific thicknesses of glass. So as you make the glass thicker, if I say so, say at this thickness, the glass would reflect no light back, and then at this thickness, let's say we'll do one more extra amount, this would be 16, and then at some proportional next thickness it might be 8, and then at some next thick, so it just keeps doing this pattern between 16% and 0% reflecting based on how thick you make this glass. So that seems a very interesting phenomenon. I've never seen it experimentally, but that's what they're saying is happening. And so, yeah, how would you account for the 0 part? Because the 0 part would have to say you couldn't say the reflection's happening on the surface or at the second surface. Because it'd be just, how would it know that it's supposed to be 0? I mean, if it was based on thickness, how would it know before the light traveled through the thickness that this was the special thickness that means no light is supposed to reflect? So there would be no way for it to reflect in stages throughout the entire thickness that it's traveling through. So there would have to be either it reflects off the top surface or it reflects off the bottom surface, but it couldn't reflect as it passes through if there was a possibility of a 0, because how would it know how thick the glass was before it got to the end of the glass to find out how thick it was? That would produce a quandary of sorts. So anyway, the real question is why do you get these properties where the average would be 8 here, of course, but even why would this be 8 and why is this 16? Those do seem like big numbers. It's it's times the average cubed instead of just doubled, which is also strange. Well, anyway, so yeah, I'll worry about that part of the equation later. Yeah, some other time. So anyway, what do I want to do with this? So that's what I've been thinking about. So I was thinking about two different circumstances. First you're trying to figure out whether this is a phenomenon of both light or the material it's interacting with. So which one is causing the effect? And if so it seems the fact that it only works with glass, light of one frequency. If you have more than one frequency of light, you'll end up changing this. You'll end up getting your average instead, just because the effect won't be effective. So you lose there's going to be a thickness of glass to get you, say, 0. Would be specific to the wavelength of the light you're using. So some other wavelength will have a different thickness of glass for which it will be at 0. So anyway, that's why it's got to be one kind of light, monochromatic. So anyway, so that's one thing to deal with. Is okay, so we have already specialized the light coming in, but what property of the light, what property could it carry that would change this interaction? So what the point is the interaction is basically, right, you got the photon coming in to a substance of some kind. And so you could argue the substance will naturally have an arrangement. So let's say the atoms were something like just, water. You could argue that the water arranges itself in a specific way, and that certain electrons would be more likely to encounter a photon coming in because they would be in an arrangement where they're easily hit, because they're the first thing you encounter. And you could say that based on the thickness of the glass would change perhaps the rotation of an atom. So say if the rotation, well, that's the best way to draw it. Say if that's the rotation, was two little atoms, two little atoms and one big atom. As you rotated, you could rotate that atom into different configurations depending on how it was restricted within this surfaces. So these two surfaces would kind of be like some sort of device that's crushing them. As you make the distance between these two surfaces, as you change how the atoms themselves arrange, and there might be something like a clockwork spin to how that arrangement manifests. So they would just take, as I made these two surfaces, if I tiny pushing them together, these atoms would slowly arrange themselves by turning in position, and that turn in position would be reflected in a very different outcome. What the hell is that? In a very different outcome in terms of whether there's going to be a reflection or not. So in position A, you could say this is position A would be the triangle this way, and this would be position B. So in this position, get the camera in the right place. In this position, there would be a high likelihood, a 16% likelihood of light being reflected. And if the atoms are in this position, there would be a 0% likelihood of the light coming back. So that could possibly be one type of explanation, but I don't think that would work for water. I mean, the effect still works in water, but it's at different percentages. And I suppose it would still work, because even liquid water, even though the molecules are moving around a lot more, they would still tend to find completeness. There wouldn't be empty space technically between the atoms of water. Water is very cohesive, so it sticks to itself, so there technically wouldn't be any space between the water molecules, and so any compression of the surface size would likely change how the molecules are arranged, so there could be this clockwork effect. So for this case, you could say this is the variable that's creating this. Instead of getting this straight line, always the same thing, this is what's creating the variability of the reflection. So sorry, I'm not aiming this camera well at all. So the variability is being caused, that wave is being caused by a change in how the molecules within the substance are arranged based on how they're compressed, and most specifically how the electrons in the substance are arranged, because the electrons are the ones doing most of the photon refracting. So in one arrangement, the electrons are less likely to absorb a photon, and in the other arrangement, that would give you the 0, and in the other arrangement, they're more likely to absorb and emit a photon. Yeah, so that would be one explanation, is that this effect is being caused by the material the photon is interacting with. So that would be similar to saying that in the two-slit experiment, what's happening is more a function of the slit material. So if we call this the slit material, and not the photon. So the photon is just a photon, and what's affecting the photon is the pattern or clock that's built into the slit material in terms of its state. So as stated before, all matter is vibrating with heat. Heat causes vibration. I don't know what's a good way to illustrate that vibration, but everything's vibrating, and it might be vibrating at a frequency, and that frequency would be consistent with creating a pattern like this if your photons are at a harmonic frequency. So in a sense, I could be saying too that as this material got compressed, the vibration changes from being lateral, or this way and this way. Instead of vibrating this way, it starts vibrating this way because of the compression and how it causes the atoms to rearrange. And so then certain wavelengths of light would be would be affected differently because they would have a vibration that is consistent with the vibration of the material. Alright, and then so the trick with the other explanation, the other side to the story, is that the photon itself could be carrying the clockwork in it, and so it's the one carrying the variable, and that variable is manifested in some capacity that changes its absorbability based on some trigger connected with the state of the material. So just the vibration alone, that wouldn't be enough to change reflexivity, but it interacts with an effect that is part of the structure of the photon. So if a given wavelength of light in a thickness was to encounter a thickness, perhaps that wavelength, perhaps that wavelength, this length, or frequency, however you want to describe it, is synonymous with some sort of way that light has to be absorbed by electrons. And so the only way the light can be absorbed by electrons is to be of a length that is conducive or specific to how the atoms would be arranged within the material. But I'm still not coming up with anything great. But the one thing we know is that light is polarized. So we do know that there is this one variable where light can be in two different configurations. I mean, it can be in multi-configurations, but these would be what might be considered the plus and minus condition, the extreme conditions. So they can be flat or linear, horizontal or linear. And the question would be is whether there's some other aspect to that condition where they would possibly have a rotation. Say if these were spikes that rotated towards you, that they had some sort of more angular character, some other character built in besides this shape, that this shape was actually doing something. So I haven't figured what that might be. The trick for me is that as I currently perceive things, and this may change, but it seems to add up to me, is that what you have at the core are quanta, and they just move in one direction. The direction can be up, down, forward, back, sideways, whatever, but they only move that one direction, one Planck constant of distance. And that's all there is. So distance and time is dictated by the length of a quanta, and that a photon would be made out of perhaps 1 million of these. I don't know. I have to do some math to figure this out, how big a photon would be in terms of how small the quanta would be. But there can be a variable number, and so radio waves would have many millions in terms of length, and something like a gamma ray would just have maybe very few quanta in each individual photon, but many photons could be packed into a space, so they could duplicate the size of some other kind of light, in terms of they could take up just as little space because they're very small. So they're just individual segments of quanta in different lengths dictating frequency and character. So character would be decided based on the number of quanta in a particular length unseparated by a barrier. So much like the barrier of this glass having an effect on how reflective it is, the fact that the distance of the glass is meaningful, the distance of the length of quanta would be meaningful. And then the second argument I would make is that electrons, I'm sort of thinking of reconfiguring the drawing to make it look a little more angular, are two strings of photons. So they have direction in this direction as photons, but that they spin on an axis, which means they have to not only go in this direction, but that they also have to move in the other plane. So they have to move not only in this forward direction, but some number of their Planck constants are used up moving laterally. So they can move slower than the speed of light now, depending on how quickly they spin. And the key thing would be is that these things are held together like the double helix. I should do these in different colors, but that the spokes at the intersections would be photons. So photons are like a double helix DNA molecule. There are spokes that hold the two photons together. So this would be technically a photon. These bars would be photons. So these all be made out of the similar material, and the difference would just, and all we're talking really about is arrangement. And that, so as you might be able to visualize, I don't know though, so this thing can spin on this axis, that would go through the center, and that would absorb some of its speed of light. So now it would be moving slower in this direction because of that. And I would speculate that these electrons are configured in atoms in head to tail patterns, where they're locked into each other, and that those patterns are in turn locked. But anyway, that I'll have to get to. So a photon would be hitting an electron, something like this, and what is basically happening is the photon comes in, connects maybe to one of these bars, and if there's already a bar there, or even if there's not, maybe that bar is released, and so that photon is released, and this one makes the connection, or something like that. That's grabbing photons in some way. It has a way of grabbing them, and once one's grabbed, it ends up releasing another one, depending on whether this energy level would be filled or this bar would be filled. If it's not filled, then the photon would be absorbed by the electron. Yeah, alright. Well, anyway, so this is the state I'm at now. So I just have to do a little more thinking about yeah, why this zero number is interesting, that you could possibly get no reflection at all, but it just has to do with somehow not interacting with electrons. And so there has to be something about the character of a specific thickness of glass affecting the capacity of the electrons in the atoms of the material to absorb photons and release them. Yeah. I mean, I think some of these explanations are valid, but I'm not sure. I mean, I just can't make them. I can't make an explicit statement, so I'm still just thinking through that stuff. So anyway, that's just where I am right now, and we'll leave it at that as an explanation. Yeah. I'd say, yeah, it's not as tied down as I want it to be for this video, but I figured I'd make it just to state that I am, this is where I am. And what we've established, I guess, is that this effect only takes place with monochromatic light. And the real question is how much of this effect of all or nothing, the capacity to do all or nothing, the capacity, the creation of a wave-like graduated output, a proportional output that goes from 4 times the average, which I don't still understand entirely, to 0, and why thickness would create that effect. And yeah, no, I'm trying to figure out what it's established. Yeah, well, nothing's established yet, I suppose, because I'm still thinking on how the structure of a photon could carry the variable information necessary to create the effect. But there does seem to be a close relationship between the character of the photon, at least in the sense of its frequency, and the effect. So we already know that one element of the photon's character, its frequency, is strongly correlated to the effect. Yeah, okay. That's about all I've established as a pretty sure that's true kind of statement. Anyway, enough. We'll see how this went.